Have you ever wondered why glue doesn't stick to the inside of its own bottle, but the moment it touches something else, it suddenly becomes incredibly sticky? It sounds like a paradox, but the explanation is actually much simpler than you might expect. Most everyday glues are made from two key components: polymers and a solvent. In simpler terms, that's the sticky substance itself mixed with a liquid, usually water, that keeps it spreadable. As long as that water is present, the glue stays in a liquid state. So for glue to actually work, that liquid has to disappear. There are two main ways this happens: evaporation and absorption. Evaporation occurs when the glue is exposed to air. The water slowly escapes into the atmosphere, leaving behind the sticky polymers that harden and form a bond. This is why thin layers of glue dry much faster. More surface area is exposed, allowing the water to escape quickly. But if the glue is applied too thickly, the inner layers are cut off from air, slowing the entire process down. Absorption, on the other hand, depends on the material you're gluing. Some surfaces, like paper, wood, or cardboard, act almost like sponges. They pull the water out of the glue, speeding up the drying process. But smoother, denser materials like metal or stone don't absorb much at all, which makes bonding more difficult. So in simple terms, remove the water and the glue sets. But what about super glue? That's where things get interesting. Unlike regular glue, super glue doesn't rely on losing water. It actually reacts with it. It's made from compounds called cyanoacrylates, which remain stable in the bottle but rapidly harden when they come into contact with moisture. Even the tiny amount of water in the air, or on your skin, is enough to trigger a fast chemical reaction that locks materials together almost instantly. That's also why it's so easy to accidentally glue your fingers together. Your skin naturally has moisture on it. So why doesn't super glue stick inside its own container? Two reasons. First, the bottle is designed to be nearly airtight, limiting exposure to moisture in the air. Without that moisture, the reaction can't start. And second, the inside of the container is made from materials like polyethylene, a type of plastic with a very low surface energy. In practical terms, that means it's extremely non-stick, so even if a reaction begins, the glue struggles to bond to it. What seems like a simple, everyday object is actually a perfect example of chemistry in action, where airflow, material properties, and molecular reactions all work together in ways we rarely notice. And once you understand it, that mystery of glue not sticking to itself isn't so mysterious after all.